Right. Hello and welcome, everyone. Thank you very much for joining us for today's session of the online MuleSoft Meetup. My name is Royston Lobo, and I am one of your Meetup leaders today, and I'll be taking you through this session. So in case you're joining us for the first time, I want to introduce you to the organizing committee for the online Meetup group. So we've got Manik and Sandeep, who are based in America. We have Angel, who's based in the UK, and me, that's Royston, second from the left. And I'm based in Singapore at the moment. So our group runs events multiple times a month. The best way to be informed about the events are to join the group via the link on the screen, and you'll be notified about all events that are coming up. The good news with our group is that all previous events are also recorded, and all the slides and material are available for you to view. So if you have not had a chance to be part of our group for a very long time, I do recommend you go through previous meetups and have a look at content that might be of interest to you. Susmit himself has presented on this group a number of times as well. Since we are a virtual meetup today, here are some guidelines to help us. So there is a chat function within this platform that is available for you. So please use that chat to introduce yourself or to share any useful information or comments. We also have a Q&A link, which is currently visible on screen, and I will also paste that link in the chat as well very soon. It's useful for us to have a single link with all the questions, because then we can present them at the end and have Susmit answer them. So please use the link for the questions, but you can use the chat for any general commentary. As with our events as usual, the slides and recordings will be shared within 24 hours on the same page as the event. So you don't need to watch out for any particular emails. I typically try and do it within the next 2 to 4 hours. All right, so I'll just take you through some community announcements that are relevant for people in the community, and then we'll get started with our topic. So the first announcement is all about meetups. So we are towards the tail end of October, but that means that there's still a number of meetups that are happening. I wanted to make a call out that a number of groups are looking for speakers for their meetups. So specifically the communication media technology, communication, and nonprofit organizations. So if you have experience in these sectors, or if you're currently working in one of them and you feel like you might have a relevant topic to share, please reach out to these community members or community groups. You can contact the organizer, and I'm sure they'd love to hear more about what you have in mind. Beyond this, we have virtual meetups in a number of cities across the world at the moment. And one of the benefits of being in the current state is that you can join meetups from anywhere in the world. So feel free to browse the list of events. That's the last link, so that you can find out all upcoming events as well. All right, over to the MuleSoft Hackathon. So some of you may not have known that the MuleSoft Hackathon is currently running and is accepting submissions until the 1st of November. So you have just about 10 days or so to put in your submission. Submissions it is a free competition to enter, and it is completely virtual, which means that you don't need to be located in a specific location. However, there are some entry requirements. Specifically, you need to be a resident of the countries that are listed on the slide. And I do recommend you looking through the rules in order to find out what's needed to be done. There is a link on the screen, mulesoft.devpost.com. Please visit this link to find out all the information that you need to know. There are some awesome prizes, and we'll be announcing winners in less than a month. So looking forward to seeing submissions from you in the community. A couple more announcements around Mule 4.4 and Studio 11. So the latest version of the Mule runtime 4.4 was released last month, if I recall correctly. Here are some of the features that are part of that release, as well as the Studio 7.11, which is what comes with 4.4 bundle. So if you are using Mule 4 and Studio 7, that may be a good idea for you to upgrade to the latest version and enjoy some of the benefits that have come along. Just a few reminders around product announcements as well. So Transit Gateway support for AWS was launched last month. This is self-service and is a massive benefit to anyone who's got a large AWS landscape or wants to have more flexibility with how their Cloud Hub VPC talks to the rest of their corporate network. So if this is something that you've been waiting for, I strongly recommend reading through the release information and seeing if it makes sense for you to adopt. Connector updates for you. So there have been a number of updates and new connectors released in the last few weeks. All the items on the left, those are new connectors. So we now have connectors for Gmail, Microsoft Excel, Snowflake, among others. There have also been enhancements made to existing connectors. Now, I know many of you are very creative. So if you're looking to use these connectors in your hackathon submissions, you might potentially see some ideas coming up with it. For anyone who is using Runtime Fabric, we have the latest version of Runtime Fabric that is now available, version 1.10. If you are a Runtime Fabric user, I'm going to assume that you're interested in these features, but it's important that you're aware of what the latest version is and potentially have a plan if you want to adopt these features as well. All right, moving on to Friends of Max. So we do have some Friends of Max videos that have been launched over the last few weeks. These are short videos, typically between 5 and 10 minutes, and they cover a number of different topics in the platform. Everything from how to set up connected apps to securing your APIs using OAuth. So if you haven't been on top of your MuleSoft knowledge or you're looking for some information to share with the team on a topic, this is a good way of getting that introductory level information on a number of different topics in the platform. All right, so just as a reminder, all slides and content will be published on the meetup page later today. I will now pass on over to Susmit, who's going to give us his presentation on Introduction to GraphQL and building a GraphQL extension using Mule SDK. So Susmit, I will stop sharing, and in the meanwhile, I will share a little bit about you. So just please put it up, bring up your screen when you're ready. So for those of you who don't know Susmit is a valued member of the MuleSoft community who's joining us from Sydney today. He has been sharing with the online group for more than 2 years, if I remember correctly. And he's always interested in exploring the bleeding edge of APIs and integration. So it wasn't a surprise to me when he came to me with this topic, because it's not something many people are working on, but it's something that more and more people need to know about. So I'm hoping that all of you in the audience are able to pay attention and get a better understanding of GraphQL through this presentation. All right, Susmit, are you ready to take it away?
Yeah, sure. Yeah, thanks, Royston, and thanks everyone from joining from different parts of the world. Today, the agenda is to discuss about GraphQL. We'll give a brief introduction to GraphQL and understand how a GraphQL API can be integrated with MuleSoft using its SDK. Okay, so this is about me. I'm a solution architect based out of Sydney, Australia. And this is the first time I'm presenting in a virtual MuleSoft meetup. So thanks MuleSoft for giving me that opportunity. Okay, so this sums up the agenda for today. We're going to discuss about GraphQL. It's relevant for people who are not having much exposure to this particular topic. So we'll go through some basic concepts and understand the advantages, disadvantages, and then we'll go through something we call a GraphQL Java API, which we'll use for integrating with provided by MuleSoft to build a GraphQL custom extension. And we'll then look into a problem called N+1 problem. And it's a common problem with GraphQL implementations. And we'll also see how we can solve that N+1 problem. And we'll have a demo to showcase that. And then we'll move on to the question and answer session. Okay. So to start with, GraphQL is basically an implementation of a type system. It is a query and manipulation language for an API. It is nothing more, nothing less than that. It's an aggregation logic for your data that you fetch from different sources, and it's a framework that supports a query and manipulation language that you can provide to your API for fetching or manipulating data. So it was initially developed by Facebook in 2012, and then it was made open source in 2015. The official website is called graphql.org. And as I mentioned, it's just a framework which helps you aggregate data and resolve your different data types from underlying resources. So it's not tied to any specific database or storage engine. Rather, it's just a framework. And GraphQL is quite efficient, powerful, alternative to REST. We'll see when we go through the advantages of GraphQL to understand how we can compare it with REST and what are the advantages and disadvantages. And GraphQL server usually exposes a single endpoint, contrary to how you implement REST APIs, and it responds precisely the data that the consumer needs. So we'll go through concepts like overfetching and underfetching to understand it better. Right, so this is a comparison between GraphQL and REST. So as mentioned in the previous slide, it's a single endpoint where you'd implement your entire data. You make it fully available through a single endpoint instead of how you organize it in the context of REST. So if you can think of users, projects, and tasks, if you're implementing that data structure using REST, you have to implement a resource definition for each entity. Whereas in GraphQL, you'll have a single endpoint, and that will expose uh, the entire data set in a graph format to the consumer. So consumer can use a query like what you can see here to query the data from underlying resources in a hierarchical format. And what GraphQL basically do is that it resolves different entities from different resources and aggregates it and sends it back as a response. So the GraphQL server or GraphQL engine is responsible for doing that integration. We don't have to implement that aggregation logic. It's a type of aggregation you can think of. But as you can see, your data can reside in a database or hypothetically in a cache, or you can even integrate with uh, APIs from which you can fetch data to resolve different types. And yeah, so basically it's not tied to any specific resource as such. And these are the advantages and disadvantages of GraphQL. Basically, GraphQL performs better because we only allow it allows fetching the data that the consumer needs instead of doing an overfetching or underfetching. It is useful for complex systems and microservices because the underlying complexity can be virtualized, and you don't need to create multiple endpoints to expose different resources. It can all work within a single endpoint, and the underlying complexity is handled by the type resolution. We'll come to the details of how that works. And the overfetching and underfetching problems usually uh, happens with REST because the consumer may need a subset of the data that you actually fetch from your underlying resource. So what you basically end up doing is most of the time is overfetching. You fetch maybe 50 fields, but the consumer would need only 10 fields. So whenever it sends a request, you always fetch the predefined number of fields. So that's an overfetching. So you want to fetch what you need to fetch rather than fetch everything all the time. So that's overfetching. Underfetching, where you fetch information which is not sufficient, then you have to fetch more information from different other sources. So these problems exist with REST, which can be handled with a framework like GraphQL. And it supports hierarchical data structure. It is introspective in the sense that there is a concept of introspection where the consumer may want to know how the GraphQL works. So it sends an introspection request. So it gets all the metadata about your type system and returns it back to the consumer. It allows code sharing in the sense that the queries can be created as fragments and can be reused. And versioning is not required because it's flexible. You can add more information, or you can allow users to use alias so that the API contract doesn't get impacted. And there are few disadvantages, but the advantages are more compared to disadvantages, I would say, for GraphQL, because the query has a complex format. You cannot really query like you do for SQL. You cannot compare SQL with GraphQL. The QL abbreviation is a bit misleading. It's not really tied to a database, so it doesn't give you flexibility to access data like how you do using SQL. And of course, because it's not having URL paths to identify resources, so you cannot have enforced entity level security or a resource level security based on the URL path, because it exposes a single endpoint. Now we'll go through the core concepts of GraphQL. So the first thing is the schemas and types. We'll see examples to understand each one of these. So schema is basically a definition of your types, the different data types that you define. There can be scalar types or object types. The mutations, queries, and subscriptions, these are different operations that the GraphQL supports. Queries, when you want to query the information. Mutations are when you want to manipulate or change the data. And subscriptions, it allows patterns, like if you want to implement patterns like a two-way connection, like say WebSockets, where you want to subscribe and see the constant feed coming back to you. That kind of pattern can also be supported by GraphQL. Validation, so it has a by default engine which validates the request. If it's not aligned with your types that you have defined, then it will throw an error. Execution, when GraphQL actually loads your types, and you can associate what we call data fetches or type resolvers. Like you tell GraphQL that for each type or each field, how do you want to extract the data from backend? That can be executed based on request from the consumer. So that execution capability is there. There's a concept of batching. We'll go through it when we discuss about something called N+1 problem. That's a common problem with the GraphQL naive implementation. So we'll go through that. And introspection, as I mentioned before, it helps you extract the metadata about your types, and that's how client can also, it's just like exposing a RAML or an API specification to a consumer, so that the consumer understands how your API works. So by introspection, the GraphQL also provides the metadata about your types, which helps the consumer understand how your GraphQL server will work, how your type system is defined, what are the different types, what are the different entities that you have defined as part of your SDL, right? Okay, so we'll see some examples. The first example is of a schema definition language. As you can see, you can define types like how I've defined here. You can define, say, a book type. An ID is an unique identifier for a type in GraphQL. An exclamation sign tells that it's mandatory. You can define arguments. For example, if you see in a field which is authors, which is, some of the fields are scalars, some are of object type, and you can define arguments. Like for authors, if you want to filter by a country, you can define an argument. This is called an argument. And then you can have array type as well. You can define arrays with these brackets. And of course, one type can refer another type. And it's modular in nature, so you can define your SDL in multiple schema definition files. And your GraphQL API supports loading all those files before you actually generate something we call an executable schema. So we'll come to that. This is how you define your schema. And this is an example of a query. So basically, query operation has a root element called query. And then you can define different GraphQL operations. Like you can see here in the type query, I have defined two operations: book search by ID and book search using a string. So if I define, or if I want to query a book by ID, my request will look like this. I'll mention the operation at the top level. Then I define an argument. So in the bracket, you define an argument, and that can be of scalar type. It can be of an object type or an input type, as we call it. And then you define the fields you want to fetch. So here I've used a concept of alias, though the name of the book, the field name of the book is name, but actually if you see here, I've used an alias called book name because I want to. So this kind of flexibility is offered by GraphQL syntax. You want to rename a field, you can rename it based on demand. Then I've defined page count, which belongs to the book data type. And then there is authors. So authors is another type, which I've defined as a type author. And there in author, I've defined which fields I want to retrieve. So this is like something that helps us avoid overfetching. Because if you mention specific fields, your implementation can be such that you only fetch the fields that the user has requested, not everything. So it improves the performance, of course, in that sense. And then you can use, so this is an array type and this is an object type. And then I've defined a publisher, for which I want to know the ID and name. This is an example of a query. Okay. There is another concept called mutation, which helps you modify the data. So mutation supports a specific type of argument called input type, which is different from just the type. It's an input type, which can be passed as an argument. So if you see, I want to create a book, I passed a book input type, and book input type takes a field called name and page count as input, for example. And in the output, I want to retrieve the book that got created. So again, when I mention these fields, these are part of the output type, which is book. And then when I implement it, basically, I take the arguments, I create a book, and then I can return the respective information related to the book that got created. We'll see in the demo also how the mutation works. And this is an example of subscription. So as I mentioned, if you have used patterns like protocols like WebSockets, it allows two-way communication over a TCP connection. So if you want to know if you want to subscribe to a book feed where you want to know if a new book got created, you can pass a request like this to GraphQL. And each subscription operation can subscribe to one subscription type. So if I define a subscription type, I can define an operation that is tied to that particular subscription type so that I get a feed when that event or that message gets published back to me in a two-way communication. Okay, now we'll discuss about something we call a GraphQL Java API. We need to understand the API because this is integrated with SDK for building the GraphQL extension. So we'll quickly go through and understand this API on a very high level. I'll not go into the Java level and explain to you each line of Java code. That doesn't serve the purpose, but we'll try to understand the concepts there. So this is an API. It's an open source API developed by someone called Andres Marek. He currently works for Atlassian in Sydney, and that's his Twitter handle. And how this API works is that it has a type definition registry interface, and it has a runtime varying interface. So the type definition registry actually helps loading the schemas, which can reside in one or multiple files. Your schema will be first loaded into a type registry, but that registry is not sufficient for GraphQL to execute queries. Why? Because that is just a schema definition. How each field of that schema will be extracted, from which resources it will be extracted. So you basically need to bind each field of your schema or of your type to something we call data fetcher, or an alternate term used for data fetcher is type resolver. Some frameworks would call it type resolver. This particular API calls it data fetcher. So as you can see in our example, we have defined an operation called book by ID, and then there are types like authors and publishers. So if you think about data fetchers, you can define an operation at a root level because that's our query called book by ID data fetcher. For author, resolving the authors, you can define a data feature called authored data feature, right? For publisher, you can define a publisher data feature. So that is something we call a data feature. And these data features need to be bound to the type system that you have defined in your SDL. And that binding is done by a framework called runtime varying, because you need to associate, okay, this is my field that you have defined in a schema called books, and this is my book data feature. So when the books, when someone wants to extract data related to the books, then call the book data feature. And each data feature gets an object of something called data fetching environment passed to it. It's a very Java centric discussion, I understand. So you need to understand how Java works, right? So you get a data fetching environment object as an input, and that gives you these three operations, which helps you identify the context in which you're trying to resolve the data. You get the argument using a get argument method. You get to know the source object. Suppose when you're extracting information for authors, it's extracted based on the context of a book. So authors means you are extracting authors for a particular book. So you want to know what's your source. Your source is a book, and your child element, which is a parent basically. And root is actually the root element, right? So if you are defining your data as a graph, then if you want to refer to a group the root object, you can use a get root. If you want to access the parent object, you can use a get source. If you want to access the arguments that are passed to you in the data fetcher, then you have to use a get argument. But when we think about building an extension, which is very generic framework, right? It is not tied to static data fetches. If you think logically, an SDK is a generic implementation. You won't know the type system. You won't know whether your developer is using types like book or author. Might use different type. So you have to build a generic data fetching mechanism. Data fetches, authors, publishers, books, these are static data fetches, right? So for that, there is another feature called dynamic varying factory. So this particular interface provides a specific method, say get data feature, which allows you to identify the context in which the data feature is, the varying factory is invoked. And then based on that, it will return the data feature dynamically. I know if you're just listening to this for the first time, it may sound a bit complicated, but the code is there. You can always go through the code and API to understand it better. So dynamic varying factory basically allows us to dynamically associate the data features with the type definition, with the types basically. And when we bind the data features with the types, we make the schema an executable schema, which we call a GraphQL schema. Because till the type definition registry is just loads the types and validates if it's correctly defined. But it's not executable unless you associate the data features with the type. So you build an executable schema and pass it on to an engine, which we call a GraphQL server, which is another interface. And then that interface will take the executable schema, and then it is able to process requests by passing the request into the executable schema, which will then fetch the respective data based on the data fetching implementation. And then the GraphQL server will be able to associate or aggregate the data and provide a response to the consumer, right? So you can think of a type system like this and a query like this. Then you can associate with the whole GraphQL Java API, how you will implement that. But we'll see how dynamic varying factory works when we discuss about the SDK. Okay, so what we've tried to do is build a GraphQL SDK extension. And for that, we've used Mule Java SDK API. It has 4 components associated with it. And if you see the code, it just has 4 Java files. One is the extension. It defines how what different configurations we are going to associate the prefix and the extension name. But the configuration is where we want to associate the schemas and load the schema and build an executable schema based on a dynamic wiring factory implementation. So the configuration is where you locate the schemas, right? And then when the Mule application starts, basically what you do is that you put the schemas in your Mule application. You'll see how that works, and you tell the and you define the configuration to load those in your type registry. And then with the dynamic factory implementation, you bind those to a dynamic factory implementation, and then you build your executable schema. So these are concepts that you need to understand to implement the SDK. The operation is a simple operation which takes a request as input and then executes it against the GraphQL server. Because the GraphQL server is already looking up for the executable schema from the configuration. So you need to know how the GraphQL extension works to understand this. And how the dynamic factory will work. Basically, when you tie up this GraphQL Java API with your Mule flow, you can think of each Mule flow you can use as data fetcher. And you can locate those dynamically using the dynamic wiring factory implementation. So you can think of the books to be resolved using a book Mule flow called books. You can think of authors resolved by a Mule flow called authors, right? And what basically it will do, instead of calling a Java method to resolve your data, which if you're doing a pure Java implementation, you will probably implement it as a data in the data access layer using DTO objects, for example. But if you're using MuleSoft to do the data extraction, then you would use specific flows, not subflows, flows, to extract the data and pass it back to the GraphQL server so that the GraphQL server can consolidate the data and pass it back to the consumer as output, right? Okay, before we go to the N+1 problem, we'll quickly see how this works, because there's too much information already I have shared with you. So it's better we see how this works. So my GraphQL extension is basically having, as I explained to you, it has 4 files. It has a configuration, extension, operation, and a dynamic factory implementation. It's actually, I've created 2 files because when we discuss about the N+1 problem, we'll know why I've created 2 files. Yeah, so the configuration basically, I'll not go through the Java code in details, but on a very high level, you can think of this configuration loading the files. So you can see it loads multiple schemas which reside in your Mule application. So I'll use this configuration to parse and load all the schemas that are defined in my code, right? Then after the GraphQL schema, then it makes an executable schema by passing the type registry and the runtime wiring. The runtime wiring is necessary for associating your GraphQL types with the data fetchers or type resolvers. So that implementation is here. But it uses a dynamic wiring factory, and I've explained why we need a dynamic wiring factory, because it's a generic implementation. We don't have static data fetchers here. We need to dynamically resolve the data fetchers, right? And the operation basically is just resolving, taking the request, passing it on to the GraphQL server, and then passing it back into a JSON format and returning it back to the caller. So that's all it does. You can go through the code to understand how it's implemented, right? And this is built as an extension, and then you can import the extension in your Mule application. You know how it's done. If you're familiar, it works like a connector, right? So this is how it is injected in your code as an extension. And when it's injected, you'll see that coming up here. And this is how you're going to organize your Mule flow to use this extension. You'll put a GraphQL, I'm calling it a router, you can call it an extension operation here. So whenever you get a request from an HTTP endpoint, this is an HTTP endpoint I've defined. Sorry. So it just exposes one single endpoint called /GraphQL, and then it is intercepted by this router, and then it calls the respective flows. If you remember, because we are using a dynamic wiring factor implementation, so instead of data fetches, these flows act as data fetches for us. So this one would invoke the respective flows to resolve the data, right? So I've got operations like book by ID, and this is just a pattern that I've used. It's configurable. I've used to identify the flows with a prefix called GraphQL colon. Then the name should match the field name in the GraphQL type. So GraphQL colon book by ID, GraphQL colon authors, book search, publisher, etc. Right? And there's a nice tool that I'm using. It's called GraphQL. It's a freeware you can download to use it. And using GraphQL, you can actually query your schema. So I've launched this application, if you see, and I can use the GraphQL to actually extract the data. I'm actually extracting data from a single source, but as I mentioned, the advantage of GraphQL is that you can extract data from different sources. Here I'm extracting data from only one source, which is a MySQL database, for example. But you can use different sources, right? So let's try a query like called book by ID. Yeah. So if I query book by ID, it returns the data accordingly, right? And if you see that relationship between the data is in a hierarchical format, you have a book at a top level. So these fields, ID, book name, page count, these were resolved by the book by ID type resolver or data fetcher, right? But when it went to authors, this is not something resolved by the book by ID. Then it called the authors data fetcher, which is the authors flow in turn, which returned an array of the list of authors. But it also took uh, an argument called country Canada. So it filtered the authors based on this argument. If I remove this argument, which is an optional argument I have defined, it will return me all the authors, right? It returns me two authors. So Java programming written by two authors, right? But I have an option even at a child level to pass arguments, right? And resolve the types. This is the kind of flexibility GraphQL provides. So you can always compare with the REST. You don't have such flexibility in REST, right? So I'll put it back. Yeah. And we'll see what's happening in the background. You'll see, I'll clear and call again, sorry. What's happening here, right? So these are different SQLs which are getting executed. First, it's extracting the books using the ID 1. Then it's extracting the authors using a book ID as 1. But how it's getting it? It's getting it through the data fetching environment object, which I'm injecting in the attribute through the extension. And how I'm accessing it in the Mule flow, you can use a Groovy script, for example, if you're using objects to call methods. So, for example, I'm injecting my data fetching environment in the attribute as a HashMap object called environment, and it provides a method called getArgument. If you remember when we are discussing about the GraphQL API, I mentioned that you can access the arguments using the field called argument. But if you go to author, then while you're extracting the author, you need to know the. So your authors are extracted in the context of book because it's a child entity. So how you refer to the parent, if you remember, you refer to the parent by get source. But you need to use Groovy to call this because I'm injecting the GraphQL, the data fetching environment object in this attribute called environment through my SDK, right? So I think it's clear to all of you so far how I'm doing, and then you can see different SQLs are getting executed. One is for publishers as well, because I've defined sorry, I haven't shown you how I've defined the schemas. So the schemas are defined here. as part of the Mule application. You can define schemas in multiple schema files. There is a GraphQL extension built by the Mules of engineering team, but I'm sure it doesn't support multiple schema files. But the extension I built actually supports it. And in the configuration, you can define the different schemas here separated by comma. Because if you remember, in the configuration, you're loading the schemas from the configuration and by splitting it by comma, right? So this is how it works. But now we'll go back to the slides and discuss about the n+1 problem. So if you have any queries till now, you can paste in the chat, and Royston will be able to interrupt me and ask me those questions. Right. So we'll go back to the slides and discuss about the n+1 problem. Okay, so we have seen how the group get book by ID is working. So if your data structure is like this, you have books and authors. When you search by book by ID, it looked up for a particular book, and then it looked up for the authors for those books. In the next context, you can think of /book/1 is the first call, and then the second call is to an authors by passing the book ID, books, then the book ID, then the authors. Then you get all the authors for that particular book. This works fine because you get a request like this. For that, you just call one flow to extract the books and one flow to extract the authors. But think about another scenario where you have to get all the books. So currently, say in your bookstore, you have 3 books. So when you call /books, because this is not filtered by the ID, so that books type resolver will return you an array of books, which can be, say, in this case, 3 books. So you get 3 books at a book level. Then when the GraphQL server tries to extract the authors, what it will do, for each book, it will try to extract the authors. So for book 1, it will try to extract the authors as /book/1/authors. Similarly, for book 2, it will again call the authors. For book 3, it will try to resolve the authors. So it will try to resolve the authors for each element of the books type. That's how GraphQL works. But this is something we call a naive implementation. Why? Because think about a criteria you're using which returns you 50 books. Then imagine how many calls to your underlying database or whatever resource you're using to extract the data you have to make. The problem is something we call an n+1 problem, because if at a parent level you have n elements, then at a child level you have to call the child data fetcher n number of times. For each element, that child type resolver will be called. So n elements for the child level, 1 for the parent, is n+1 times you need to call to resolve the whole data, your whole data structure, right? But this is problematic because when you have different types and each type is related to the other, and you have a parent-child relationship, then the number of calls you'll end up making to the backend will be huge. So this is the naive implementation, and this is of course the extension that engineering team built had this problem as well, for which I thought, okay, let's try to solve it. The solution to that will be something like this. So when you fetch books at a parent level and it returns multiple elements at that level, instead of calling the child type resolver for each element of the parent, what we'll do, we'll try to collect the keys. Keys means the IDs of the parent element, instead of passing it to the data fetcher and calling the child data fetcher every time for each element of the parent. So in the REST terms, you can think of the books being called at the first as one invocation, and you get 3 books as a result of that. And instead of calling the authors for each book, what we'll do, we'll collect the IDs for each of these books and pass all those IDs as keys in a single call to the child for resolving the child element. Instead of passing each book ID to the author's data fetcher, we'll call the author's data fetcher passing all the IDs of the parent. if the parent is of a type array and it has multiple elements. This solves the n+1 problem, because then instead of, say, previously you were making 1 plus 3 4 calls when you have 3 books. Imagine when you have 10 books, how many calls you make? 11 calls, right? But here, irrespective of the number of books, you will always call your underlying resource 2 times. So it is a huge performance benefit you'll get, and this is how you'll solve the n+1 problem. And how you solve this problem is by using an API called data loader. It's not part of the GraphQL Java API, but it's a different API. It's another API that you have to use, which I have used in my SDK extension. And what it basically does is that instead of invoking a data feature right away, it collects the keys. So it doesn't directly call the data feature. There's an API which collects the keys. And finally, when the final key is collected, which means when it got book 1, book 2, book 3, instead of scanning through each element and calling the data feature, what it does is that it extracts, it actually goes to the, it tries to invoke the data feature at the author level, but then it decides that no, I'll not call I'll not call the data feature, but I'll rather store the key. So it stores the key for 1, then it stores the key for 2, then it stores the key for 3, and it detects that okay, it's the last key. Then it invokes the type resolver for the authors and pass all the keys to it, so that this particular type resolver can extract all the authors for all the books in one go and provide that information back to the parent for aggregating it, right? So the data loader also supports caching. You can use caching mechanism of your choice, but it will be a Java implementation because this is a Java API. And yeah, that's caching is not included in the demo today. But then we'll go back and see how this works. So if you see this particular example, I'm calling it a problematic implementation or a naive implementation, and this has that problem of n+1. So I'll clear it and I'll call an operation to show you the n+1 problem. So there is a book list query. So I'm searching books which contains C in its name. So if I call it, you see it's returning an array at the top level. So there are 2 books, one is C++, one is C, and for each book it actually fetched the authors for C++ and for C. So let's see what happened when we called it. So first it called the root level to find all the books which has a name like C. Then for each book it tried to fetch the author, where book ID equals to 2. It tries to fetch the publisher, where book ID equals to 2, right? And then you see there is another call to get the authors for book ID equals to 3. So for each book it is calling again and again, and you saw how many calls are being made to the database. This is the n+1 problem. This is a very naive implementation, not recommended for GraphQL. Now I'll stop this application and I'll run an application which actually has the GraphQL data loader implementation. So you can see the version of the extension I'm using for the problematic implementation and the one which solves it are different. So this one has that solution. So I'll just start it. Okay. Now, if you see the extension, I've used a dynamic factory and a dynamic factory DL. I've intentionally put these 2 files, but you have to use one at a time. So the dynamic wiring factory has that n+1 problem, but the dynamic factory DL, this actually solves the n+1 problem by collecting the keys because it uses a data loader implementation, right? I'll not go through the code. You can go through it and ask me questions at a later point if you try to understand how it works, right? And yep, so we'll wait for these applications to start up. Okay. And while it's starting up, I'll quickly show you something. So this is the data loading implementation. And yeah, okay, so it has started. All right, so then I will then query again. The same operation I'll query again and see how it works. Okay, it also returned me 2 books, right? Same data, same repository, but then we'll see how many calls we made to the database. Look what happened. We called the same SQL is invoked at the top level. It returned multiple books. But when we went to the authors, we didn't really call the author for all the for individual books, because the book IDs have been passed to the author data fetcher as a list of keys, right? And we use those keys to search the database uh, to fetch all the authors in one go. So we collected the book IDs and we are calling to fetch all the authors in one shot. Similarly for publisher. So it's not necessarily that you need to you will get it for only specific type resolvers. For any child element, it will be able to pass the keys to the child element. If the parent is an array and it's a collection of objects, and if you have a data loader implemented. Okay, so this is how we resolve the type, the problem of the n+1 problem. And another thing which I want to highlight to you, if you see in the side panel, the GraphQL tool is able to, show you the whole type definition. So if you see, it shows you, okay, you have these queries and you have these mutations which you can perform. So how is it able to fetch this metadata? Because all your types are in your Mule application defined in SDL, but this tool was able to, extract the metadata, your type definitions. How? That is something we call introspection. If you remember in the core concepts, we call introspection. It's a special type of query which the GraphQL API supports by default. And if you query that, it will give you the definition. The whole definition of your type system is returned as well. So it's just like exposing an API console, right, where you can browse through your API. So this tool provides, the GraphQL by default provides this type definition through an introspection, right? And that will help the consumer tool understand how your GraphQL API will work, right? So yeah, we're almost done with our presentation for today. Just one point I want to highlight. If you go through the custom SDK implementation, you'll see how I'm basically calling the Mule flows is using an API called core event, and we pass the core event to invoke a flow. So this particular extension is still at a POC stage, and the engineering team may not recommend using this type of maneuver for calling the Mule flows. So this is something which needs to be endorsed by the engineering team before you go on and use it for your production scale application. And another thing which is a limitation when we use dynamic wiring factory and tie up with MuleSoft is that the parent child relationship, we're collecting the keys, right? So, and we are doing a generic implementation, but the name of that field that identifies a particular object in your type, if that is dynamic, then your wiring factory won't be able to uh, you know uh, extract it, because we don't know what's the name of the field. So it's a limitation of this particular extension that I built, that your types need to always have an ID called ID, basically, and that's the field which we'll consider as the unique identifier for your types, and that needs to be consistent across all the types. That's a limitation. If suppose I call my author ID as an author ID, book ID as a book ID, different field names for the ID fields or the types, then of course my dynamic variant factory implementation, which is a generic implementation, we won't be able to detect because we don't know what name you have used for your the type IDs. So that's the limitation. So the two limitations that I want to highlight. Right. So that's done, and we have gone through the demo. You have seen how it works. So that sums up the session for today, and I'll be happy to take the questions now.
Excellent. Thank you very
Over
much.
to you, Ashton.
Thank you very much, Susmit. Very detailed presentation, and hopefully the audience was able to follow along. We do have some questions. So if you're able to stop sharing, I'll just present the questions on screen.
Sure.
Just to make it easier for everyone. So, moment. Right. So let me know when you can see the question on screen, and I'll just narrate it for people. Is that coming through?
Yeah.
Right. So first question is, I have used API specifications by converting some OAS endpoints to Mule API spec. Here to choose between API spec versus the Java SDK-based development. I'm new to Java / SDK and want to start from scratch on it. Any directions?
Yeah, so this Java SDK is not something every developer has to develop, right? So because this I have described as an extension to what MuleSoft provides by default. So it's like a connector. It needs to be developed before you can use it. So it's an extension that is already built. You can import it in your code and use it. It's ready to be used. So you don't need to build a Java SDK basically, and it follows a GraphQL standard. So it's a standard syntax that you have to use in alignment with the GraphQL.
Okay, thank you very much. Next question is from Mohit. So he's asked the question: the GraphQL allows caching and authorization checks at field level. Just curious why it's been quoted here under disadvantages.
Yeah, it's a very good question. Yes. So GraphQL caching, it's not mentioned as a disadvantage. What I mentioned is that it's complicated if you want to implement it, because you use data loader, and then you have to use a caching implementation using Java, and then you have to integrate with the SDK. So it becomes very complicated in that way. Otherwise, in your Mule flows, you can use object store to cache your responses, but I don't know how efficient that will be.
Thank you. Next question.
And authorization, just one point, if you go back to the previous question. So it talks about authorization checks at a field level. So authorization checks at a field level, I'm not quite sure what is meant here. If you can elaborate, that will be good.
Next question is, do we have to define a GraphQL schema separately from the Mule schema?
See, GraphQL schema will be have to be built separately, and you can put it as part of your Mule application. You can put it in the resources and look up for those schemas using the GraphQL configuration. I'm talking in the context of the custom extension that I have built. If you're
Moving on to our next question. So I'll read this out. What I'm understanding here is that we are aggregating various data sources using the GraphQL SDK with this MuleSoft extension and exposing them as GraphQL. What changes if we want to consume an already built GraphQL API using the Mule extension?
Yeah, so the extension doesn't change. It's a generic implementation, right? Mm-hmm. Only you can change that can happen is in your schemas. So you may enhance the schema, you can include new types or introduce new fields, but as I said, you don't need to really do versioning, because there is no impact from a consumer perspective unless you're removing one field. If you're removing a field or a type, that's when there will be an impact. But if you're adding new fields or new types, there will be no impact to the consumer.
Okay, thank you. Next question is that GraphQL-Java is extremely powerful, but so low level. The person is unclear of the advantages of this versus other frameworks like the ones mentioned. Do you have any comments on that? This one?
So it needs to be integrated with the MuleSoft SDK. So I found the GraphQL Java useful uh, while integrating with the SDK. So I'm not quite sure about the Kotlin. If you have a engine for Kotlin that can be integrated with the Java, because MuleSoft SDK is a Java SDK, or that I have used. You can use XML SDK as well, but you will be able to integrate it with your SDK.
Okay. Thank you. The next question is, will this generic extension be able to query objects based on criteria other than the value field, like a book name instead of book
So
ID?
you can use aliases if you want to rename your field, but this particular extension, as I mentioned in the last slide, has a limitation because if you're using a data loader implementation, you need to identify the fields, identify the keys, and you cannot identify the keys dynamically if you use different names for the keys. So it needs to be consistent if you are using this particular extension. That's a limitation, but to rename the fields from a consumer perspective, GraphQL allows you to do, apply aliases. So you can change the name when you actually query the information.
Thank you. And our next question, it's a follow-up. So, are you able to quickly mention your own experiences, the benefits of this approach versus data graph?
So Anypoint Data Graph is provided by MuleSoft as a service, right? And of course, that's a different. That's for different purpose altogether. This is an extension that you can use and have your own implementation of how you want to resolve types and how you want to define types, rather than use a service to do it for you.
Yeah, you described
And
that well.
GraphQL data graph, I think it allows only queries, and I haven't explored that much, but yeah.
Yeah, I think the best way is to probably say that data graph is GraphQL as a service which relies on all your APIs being in the Mule ecosystem, whereas what you've
This is
shown and GraphQL in general is more of a framework or a way of doing things.
correct.
So the
Yeah,
customizability is much higher if you were to use your approach. Data
yeah,
graph is essentially leveraging things that are already built within the MuleSoft platform, or at least
yeah, yeah,
it needs the underlying foundation has to be built already. Whereas with potentially your approach, it's very much building it from scratch or orchestrating from scratch.
yeah.
It's one way
Ah,
to describe it.
yeah,
But yeah, it's not a synonymous. Data graph is not just GraphQL. So for
yeah,
anyone who's thinking along those lines, it leverages the same philosophy, but it's a different. It's serving a different purpose. All right. In the interest of time, I am going to cut it off over there since we are past the hour mark as well. We do have some people who are very interested in this topic, Susmit. I was wondering if people are interested and want to speak to you more or learn more about this, do you have any tips with how they can connect with you or
yeah. You
grow their
can.
knowledge in this space?
Yes, you can connect to me in LinkedIn, and the extension is there in GitHub as a public repository. You can always fork it. I'll quickly answer the question from Mohit in the chat.
Yep.
Yes, it's talking about the Apollo server. That's a JavaScript implementation, and yes, GraphQL support directives. Yes, you can use directives in your type definition. But this particular extension doesn't support it, but we can always enhance it to support directives as well. Yeah.
Thank you. Mohit has definitely been a very active participant today, so I think he might be someone who might be reaching out to you with more questions and comments. On
Yeah.
behalf of all the participants, Susmit, I wanted to say a huge thank you for taking the time and effort to prepare and to present. For anyone in the audience, if you'd like to thank Susmit, please fill in the feedback survey that you're going to get later today, and share any comments and feedback that you have, including any thank you messages, and I'll pass them on to Susmit later on.
Thank you.
As a
Thanks, everyone.
reminder, all the recording and materials will be put up on the event page in the next few hours, typically within 24 hours. We always are open to feedback about the meetup in general. So if you have any suggestions on content or anything that we could improve, please let us know. I am looking forward to the next time you join us on the online meetups this week. But until then, I wish you well, and thank you everyone for joining us today.
Thanks, everyone.